Global copper demand is expected to rise by 30% from 2020 to 2030. Demand for high-purity copper is also expected to increase due to the advancements in semiconductor technology and other high-purity copper markets across the globe. As one of the countries with the largest reserves, the Philippines can be a key player in the global market for copper. Aside from this, the rising demand for copper also results in the depletion of high-grade and easily processed copper resources, thus forcing industries to mine and process complex or lower-grade copper deposits. Thus, the availability of an alternative copper extraction process capable of treating these ores will be beneficial to the copper industry in the Philippines. The Philippine copper industry envisions a sustainable and fully integrated copper industry to maximize the value of our copper resources. The fully integrated copper industry is anticipated to be fulfilled by the operation of select world-class copper mines, development of a wire rod casting facility, and promotion of higher value copper products. Our program aims to support this vision by addressing the gaps in the copper industry.
To actualize this vision, the Alternative and Advanced Copper Processing Technology, or ACT program, was developed. The main objective of the program is to develop alternative and advanced technologies for processing of copper ore, high-purity copper cathodes, and copper rods. This presentation is about the first of the three approved projects of the OSTP shared, the Cu-HySolvEr, or the copper hydrometallurgical and solvometallurgical extraction from sulfides and oxides. There are three operating copper mines and one copper processing plant in the Philippines. Though processing is also done in the operating mines, it is limited to mineral processing, producing only copper concentrates. The only processing plant in the country involves pyrometallurgy in extracting copper, which involves melting of the copper concentrates at extremely high temperatures. As the current copper concentrate production from the local mines cannot meet the logistical and input requirement of the existing processing plant, the copper concentrates are directly shipped to other countries for processing. Aside from this, the existing copper mines are only capable of recovering copper sulfides from the ore, and low-grade copper existing as oxides usually go to the gangue and waste material of the mines. Thus, there is a need for a fully integrated copper mining and processing industry for our country to fully maximize the value of our copper resource. The processing plant must be capable of treating local copper ores and producing metallic copper. The extraction method must also be capable of recovering copper from low-grade oxides. The technology must be affordable, which the mining industries can easily adapt. As the gap between the mining and processing industry is difficult to fill because of the limitations of the available processing sector, Cu-HySolvEr aims to provide an alternative processing route for extraction of copper. Two methods will be developed. The first one will involve hydrometallurgy, which is based on a well-studied extraction process for copper. The second method will involve solvometallurgy, an emerging technology in extractive metallurgy, which is expected to be cleaner and more efficient process than hydrometallurgy. These two methods involve similar processes. The only difference is the media being used. The project will be beneficial to the copper industry. Through this project, mining industries will be able to produce high-quality copper product from our local ores, which will increase their productivity and result into economic growth. As one of the major issues hurdled against mining industries is the unavailability of downstream processing, efforts on downstream processing increases the trust of the public to mining. This project will also strengthen the partnership between the academe and industry, which will strengthen the research capabilities of the country, increase the professionals' expertise in hydrometallurgy, and develop interest in solvometallurgy, which is an emerging technology. Our team is composed of licensed metallurgical engineers from the University of the Philippines, Diliman. I am acting as the project leader, and with me is Assistant Professor Joy Maniaul. This ends my presentation. Thank you for listening.